CSIR NET Math 2018 December. Booklet code C, question number 46. Consider the two-dimensional motion of mass M and attached to one end of spring whose other end is fixed. Let K be spring constant. Then the T equal to half M r dot square plus r theta dot the whole square, and V equal to half K r square. Then which option is correct? Number 1, r is an ignorable coordinate. Option 2, r is not an ignorable coordinate. Theta is not an ignorable coordinate. Option 3, r square theta dot remain constant throughout the motion. And option 4, r theta dot remain constant throughout the motion. So now the solution. This question from classical mechanics. Lagrangian L equal to T minus B equal to half M r dot square plus r square theta dot square, and minus V is half K r square. Now L is a function of q1 q2 dot 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 qn and q1 dot q2 dot qn dot. So here q1 equal to r and q2 equal to theta. Now we know that phi equal to del L del qi dot. So p1 equal to del L del q1 dot and p2 equal to del L del q2 dot. So p1 equal to del L del r dot and p2 equal to del L del theta dot. This is equal to derivative L with respect to r dot, then half M into 2r dot, which is equal to M r dot, and derivative with respect to theta dot, then half M r square into 2 theta dot, which is equal to M r square theta dot. Now P1 equal to M r dot, so r dot equal to P1 by M. We get r dot equal to P1 by M, and theta dot equal to P2 by M r square. P2 by M r square. This is theta dot. Then we know that Hamiltonian A is equal to summation pi qi dot minus L. So this is equal to p1 q1 dot plus p2 q2 dot minus L. So this is equal to p1 q1 dot means r dot plus p2 theta dot minus L. Now r dot is p1 by M, so p1 square by M plus p2 square by M r square by minus L. What is L? L is half M r dot square. Now what is r dot? R dot is p1 by M, so r dot square. Here is r dot square, so p1 square M square plus r square theta dot square is p2 square by M square r to the power 4 plus half K r square. So now here M and M cancel, and M and M cancel out, and r square. So we can write one line p square m plus p2 square m r square minus half p1 square m plus p2 square m r square plus half k r square, right? Then this is equal to half, this is 2 minus 1, so 1 and half p1 square m plus half p2 square m r square plus half k r square, right? Now this is Hamiltonian H. Now Hamiltonian equation of motion. Hamiltonian equation of motion, we know that. What is Hamiltonian equation of motion? That is qi dot equal to del h del pi and minus pi dot is equal to del h del r dot, so here qi, right? Now here I equal to 1 and 2, so put q1 dot equal to del h del p1 and q2 dot which is equal to del h del p2 and here minus p1 dot equal to del h del q1 and minus p2 dot equal to del h del q2. Next, what is q1 dot? Q1 dot is r dot, so we write r dot is equal to q1 dot is del h del p1, right? So derivative h with respect to p1, here is h, so derivative h with respect to p1, so what we get right here, half 2p1 into m, here the derivative with respect to p1, so half here m is here is m, so you get p1 by m, right? Now here p1 dot minus p1 dot is equal to del h del q1 and also, so what is p1 dot? P1 dot is, so right, minus p1 dot is equal to, first we write this minus p1 dot is equal to del h del q1, that is del h del r, right? Now minus p2 dot is equal to del H del Q2, that is del H del theta. And also from here Q2 dot is del H del P2. What is Q2 dot? Q2 dot is theta dot. So theta dot is equal to del H del P2. Here Q2 dot is del H del P2. So del theta dot equal to del H del P2. So derivative H with respect to P2. Then what we will get? We get half 2P2 by m r square. So 2 cancel. So we get P2 by m r square, and here is theta dot. So we finally get m r square theta dot is equal to P2, and here we get P2 dot is equal to minus H del theta, which implies del H del theta, but here H is given here. So here if we derivative H with respect to theta, then this is 0. So del H del theta is 0. So P2 dot equal to 0. Here implies P2 is constant. Right, P2 is constant. Then here we put P2 is constant, then m r square theta dot is constant, and mass obviously constant, so r square theta dot is constant by m, which is constant. So we get r square theta dot is constant. Right, so check option. First option, r is ignorable coordinate, so which is cancel. Option theta is not ignorable coordinate, and here option 3 is r square theta dot remain constant throughout the motion. Here we get r square theta dot is constant. So option 3 obviously right answer.